Okay, so in section 1.2, we're going to talk about segments and congruence. Now, there are a few terms at the beginning of this lesson. One of them is a postulate, otherwise known as an axiom, and that is just a rule in geometry that we accept without a proof. So it's just a generalization, a rule that is followed in geometry, but it doesn't have to be mathematically proven. If we have a theorem, then that is a rule that is proven. So like things like the Pythagorean theorem, anything that says a theorem, it has been proven to be mathematically accurate for multiple scenarios over the years. We know that a coordinate is a number that corresponds to an ordered pair. So we've seen those in Algebra 1 as an X and a Y. Coordinate with a comma in the middle and parentheses around the edges. And then a distance between 2 points is the absolute value of the difference of those coordinates. When we write the distance of a segment between 2 points on a segment or the length of a segment, we write it like this, in this form, like they have it AB right here with no bar or anything over it. So anytime you see two letters that are written beside each other with no bars or no symbol over it, it is talking about the length or the measure of that segment. All right, we're going to move right along and talk about the segment addition postulate. The segment addition postulate is if we have a point between two other points, then the sum of the two smaller segments' lengths will equal the length of the longer segment. So, for example, right here, B is in between points A and point C on segment AC. And then so the length of AC, which is the longer segment, will be the length of the segment AB and the other small segment BC combined together. I like to simplify this in saying little segment plus little segment equals the big segment. Little plus little equals the big. Okay? So, for example, this one is on page 10 and number 3 in the book. I have this segment right here drawn, and I have segment. It says find the length of segment XZ, which is the entire segment given in this picture. And it tells me the small segment XY is 23 units, and the small segment YZ is 50 units. So if I want to find XZ, that's the large one. So I'm going to say that's going to be the same as the length of XY plus the length of segment YZ. So the length of XY is 23 units. The length of YZ is 50 units. So if I add them together, I don't know why I wrote that. The length of XZ will be 23 plus 50, which is 73 units. Moving right along, this one's a little bit different. This time they give us the length of the entire large segment, and we have to find the length of one of the smaller segments. It says find the length of GH. Well, GH is this segment right here. That's the one we're trying to find. So remember I told you little plus little equals big. So I've got the little segment FG and little segment GH, and added those together. Those equal the segment length for FH. So the length of FG is 21 units. GH, that's the one we don't know, so I'm going to leave it GH there. And the length of the whole segment, FH, is 36 units. So to solve for GH, I would subtract 21 from 36. So the length of GH is going to be 36 minus 21, which is 15 units. Similarly, if we were trying to find the length of CD, in this example, I have the length of the entire segment for CE is 42 units. This little segment right here is 17. It says to find the length of CD, which is going to be this little segment right here. So to find that, the measure of CD is going to end up equaling 42 minus 17. So the length of CD is going to equal 25 units. All right, let's talk about congruence and equal measures. Congruent segments are line segments that have the same length. The way we show this in pictures is by using these little tick marks right here. So if you see two line segments that have the same number of tick marks, that means they are equal measures. Now, when we're talking about measures, remember that's when we see the symbol with no bar. Okay? So that means you're talking about the measure of that segment or the length of that segment. So if we're talking about lengths or measures, we're going to say that those are equal to each other. If we're talking about the actual line segments themselves with the little bar over them, then we're going to say they are congruent to each other. Now, congruent is used by the symbol that looks like an equal sign with a little squiggle bar over it. So we would say measures are equal, segments are congruent. Okay. Last example we did today was page 11, problem number 5 out of the book. And segment addition postulate, they tell me that the length of the entire segment V to X is 144 units. And they tell me the short segment VW is 37 units. They want us to find the length of segment WX, which is this little segment right here. So the way we can find that is little plus little equals big. So if I know the big segment length, which is 144, I can subtract one of the smaller segments, which is 37, and get that length. So I believe the answer is going to be the length of WX equals 107. So that is all for section 1.2. Have a good day.